All right, everyone. We are going to start with section 2.1. We are starting unit 2. And you can go to Notes and Outlines in MyLabs Plus and follow along with me in the notes posted there if that helps you. And we are going to start off with piecewise functions, and you're going to see a couple videos on this exact same function. So if you're taking notes, you want to go ahead and write that down. And just so you know, once we cover this example, you are going to be able to go to the homework for 2.1 and complete numbers 6 through 8. So homework numbers 6 through 8, you're going to be able to complete for this section. All right, so this is a new topic, and we introduced this idea in our lab of piecewise functions with our Olympic swimming lab, and the end result of our lab was that we had a piecewise function that represented the men's swimming times, where we saw before that certain year in 76 there was a greater slope than after. And so basically a piecewise function is a function that comes in pieces, and this is a function with 3 pieces. And sometimes there's a function that has 2 pieces, and sometimes there's functions that have more pieces. And when you have one function that has multiple pieces, this part of the function is very important because it's telling you where the piece fits on a coordinate plane and what the particular domain is for each piece. So we have let f of x equal x plus 1 for x less than -2, 5 for x greater than or equal to -2 and less than or equal to 3, and x squared for x greater than 3. And each piece has its particular domain, and so we're going to evaluate the following. Okay, we already know from unit 1 what evaluate means. It basically means plugging the value into the function and simplifying. So when we look at these first 3 initial values, we want to plug them into a particular piece. We do not take the value and plug it into each piece. We have to pick the correct one and make sure that we're using the right domain. So for instance, let me erase my red going on here. So we've got a function that comes in pieces. All right, so the first thing we want to do is evaluate f of 4. F at 4, remember f represents the name of the function, and 4 is the constant that you're plugging in for the variable. Well, we're going to look at where the domain works. So 4 actually works for this piece of the function, right? Because 4 is greater than 3, right? This is for when x is greater than 3. So it works for this third piece of the function. So we're actually going to evaluate it in x squared. So we get, all we do is plug it in, we get 4 squared, which is equal to 16. And I'm going to write that as an input-output because we're going to use this later when we look at a picture of this and we graph it. So the input is 4, the output is 16. So I have a coordinate point of 4, 16. And I have another little board that I'm going to mark that on for later. Okay, we're going to use that later, 4, 16. Then we want to look at what f of 0 is. So you want to look at the domain area of the function, okay, and see where 0 fits in. Okay, is 0 less than -2? No. Is 0 in between -2 and 3? Yes. So it works for the constant part of the function 5. Now this one's a little strange because there's no variable to plug in 0 for. It's just constant. So when we solve this, actually f of 0 is just equal to 5. There's nowhere to plug it in. This is a constant for all of these values. Anywhere from -2 to 3 is simply 5. So again, we have our input, output. So we have 0 and 5. And again, I'm going to note that on another board for later. And lastly, on this example, we have f of -5. And of course, -5 is going to fit into this part of the function, right? -5 is less than -2, so that works for x plus 1. So we plug in -5 for x, and we get -5 plus 1 is equal to -4. So again, our input-output here is -5, -4. Okay, and that is simply how you evaluate a piecewise function. You look for which part of the domain the input works with, and that is the part that you plug it into. Okay, so that part is not too bad. So that is evaluating a piecewise function. And that particularly will help you with number 6.